we should start with Dr. Loon first, and I will make sure that my system is working. So I will introduce Dr. Loon then. He's going to give us a talk on uh, his talk he's sharing right now. So that's great. Creative data science learning, unveiling the impact of scaffolding learning through data storytelling. Welcome, Dr. Loon.
Thank you. So I will be presenting with my collaborator, Dr. Amanda Soon.
Mhm.
My third collaborator, Miss Fan YIYUN. She's actually
Mhm.
online now, but she won't be presenting as she's not feeling too well. So let me
Okay.
begin. Hello, everyone. Well, depending on where you are located now, good morning, good afternoon, or good evening. We are
Good
from
evening.
the National University of Singapore. I am Loon, and together with Amanda Soon and Fan YIYUN, we are pleased to do a presentation on our study entitled Creative Data Science Learning, Unveiling the Impact of Scaffolding Learning Through Data Storytelling. We would like to acknowledge our funding body, the Ministry of Education Singapore, through which the Tertiary Education Research Fund funded this study. In recent years, data science education has become increasingly popular. A tertiary education in data science is closely associated with the traditional STEM subjects of science, technology, engineering, and mathematics. While this association may not be surprising, it is now widely accepted that a sound understanding of data concepts is crucial even in non-STEM disciplines like finance, politics, or linguistics. In many of these disciplines, handling large data sets is becoming necessary. For the key concept in this presentation, data storytelling, there are various definitions of this term. Informally, it is a method of communicating insights gleaned from a data set using data storytelling elements. For a more technical definition, our research aligns with the definition found in YIYUN 2016, which describes data storytelling, or DS for short, as a procedure where information from a dataset is compressed and key elements are conveyed through a series of narratives and data visualizations. In 2024, we began to approach the concept of scaffolding systematically. The idea of scaffolding was originally proposed by Wood et al. In 1976 to describe facilitative tools and skills that foster learner autonomy. Through a four-stage framework, we implemented scaffolding learning through data storytelling in an introductory data science course. 180 students were enrolled in this initial study and participated in each of the four stages of this experiment. While the observations from the study were encouraging, there were limitations to the study. For example, our data consisted only 180 students, which was less than 10% of the total enrollment for the course. Another limitation was the self-learning nature of students, where they have to facilitate their learning without the direct help from teachers. Subsequently, our next attempt focused on the in-person focus group activities and interviews conducted in small groups of 5 to 6 students per group. A total of 4 data stories were presented to each student, and this was followed by a reflection survey, which comprises of a series of questions to assess the sentiments of the students after having read the data stories. These surveys also included several technical questions on data concepts that were mentioned in the stories. Each session concludes with a group discussion where we attempt to delve deeper into the experiences, thoughts, and seek suggestions from the students through a collection of carefully curated interview questions. Our findings from this second focus on data storytelling were encouraging, and a manuscript has been written that is currently under review. In essence, we have made changes to our materials and assessment items, and the findings are what is presented at this conference. Currently, we aim to revise our materials to try to measure whether students' perceptions of data storytelling and proficiency in answering technical questions on data concepts can be improved. We hope to improve the structure of our scaffold learning with an updated, self-regulated learning framework and integrate DS principles into the introductory data science course material. I will now hand over the next part of the presentation to Amanda. Thank you.
Thank you, Loon. Okay, data storytelling has been applied to various educational settings. The most common is its application to learning dashboards to communicate learning analytics to teachers and students. By learning analytics, we basically mean the use of data to identify patterns in students' learning, offering valuable insights into their performance. DS can also have different forms in educational settings. For instance, creative comics design. This is particularly innovative in the format promoting learning to people who are not essentially interested in data literacy skills. In addition, DS can also be used in curriculum designs. A recent work by McDowell and Turk introduced the concept of data storytelling education, which moves students from being customers of data stories to being the creators of them. Though we see the values of DS in data science education, we need to address some concerns. When teachers try to deliver data and knowledge to students, can data storytelling serve as a good tool when incorporated into a course? Can it serve as good content genre for learning? Can students offer useful learning analytics that benefit the future? Hence, by the end of this study, we hope to answer the following two research questions. How can generic data storytelling elements be incorporated in the course curriculum to improve learning perception and performance? Does this design affect learning perception and performance as learners progress through the course? In our attempt to answer the first research question, we need to first ask ourselves, what makes a good data story? Ryan and Nafik offered some generic principles for data storytelling, namely, DS should be goal-oriented, present appropriate visualizations, guide audience attention to desired information, and it should simplify presentation of the visuals. After looking at the principles needed for data storytelling, the next question we need to answer is, how can we integrate DS into a course? Our approach starts with the concept of scaffolding. In 2001, Hadwin and Wynn came up with the concept of tacit scaffold. It refers to the embedded tools that help to cue students to attend to aspects of their studying without explicitly directing or instructing those studying activities. The process includes task understanding, setting goals and planning, which supports the development of self-regulated learning. In this study, we propose a framework that essentially incorporates data storytelling content within a course curriculum through a scaffolding process. Our framework consists of 4 stages. In the first stage, students are presented with raw data and its analysis in the format of stories. The second stage includes the use of scaffolding in the stories, which are designed to follow the flow of the content taught in the course over time. In the third stage, students are assessed through questions that target their learning perceptions and comprehensions of the knowledge presented. Finally, we obtain new insights through their responses to produce more updated and higher quality learning content. Our team conducted an experiment to test this framework, similar in nature to the first one described by Loon earlier, where only 180 students were enrolled. However, the 4 data stories and assessment questions used in this experiment were great improvements on the earlier materials used. In addition, for this round of the study, we had a total of 992 participants. All the 4 stories were constructed based on the knowledge and data literacy skills introduced in the course, following the principles by Ryan and Nafik. We made sure that each story followed the flow of task understanding, setting goals and planning, enacting study tactics, and evaluating and adapting meta connection. Additionally, we ensured that each story never explicitly directs or instructs students' learning, but encourages their self-directed learning instead. Here we present an excerpt from one of our data stories involving the use of scatter plots and a discussion of what the relationship between 2 numerical variables can mean. Along with the main content of the story, we also provide prompts as shown here to invoke students' thinking. In addition, we present data via visualization tools and provide explanations to aid students' understanding of the figures used. For assessing learning perception, questions were created to check whether students perceive themselves as having a full, limited, or confused understanding of knowledge. For learning comprehension, different MCQs or MRQs were created to check their understanding of knowledge in an objective way. For instance, we have questions for filtering eligible participants, questions emphasizing self-perception on learning, and factors related to learning attention and interest. Here is an example for learning comprehension question, where students' comprehension of knowledge is tested. For analysis, a Likert rating of yes, no, and uncertain were used. Yes is defined as a good self-perceived understanding, whereas no and uncertain are defined as limited and confused understanding. Similarly, for learning comprehension, a correct answer given is considered as a good understanding of knowledge. Partial or incorrect answers show students confused or limited understanding. Then the comparison between self-perceived understanding and students' true understanding were made. In Survey 1, based on the knowledge of the first data story, there were generally over 85% of students that reported a self-perceived good understanding for two knowledge points: summary statistics and symmetry. More than 73% of students also reported their strong learning attention and interest. But does that mean they had good perceptions, or does it indicate a positive learning trend? To verify this, a comparison between self-perception and true comprehension was made. The finding shows, for the knowledge point of summary statistics, there were only 84.2% of students who chose the correct options in Survey 1. For symmetry, there are surprisingly more students that actually understood the concept but thought they did not. If we only look at students' self-perceived learning attention and interest, the initial decline in both self-perception, intention, and interest following the first learning material suggests that either the novelty of the intervention wore off quickly or the second material may not have engaged students as effectively. However, the general upward trend in both measures for the subsequent materials indicates a partial recovery, suggesting that the latter materials were better aligned with students' cognitive engagement and emotional interest. The final scores, though not as high as a starting point, reflect a certain stabilization. In Survey 2, again, a similar comparison was made. This time, declines in both association and removing outliers comprehension was observed. This indicates that students thought they had understood these two knowledge points well, but only 70.1% and 63% of them, respectively, did choose the correct options in reality. For Survey 3, similar trends were observed, but this time, more students failed to understand the knowledge points. For the concept of correlation coefficient, only 40.9% of the yes students chose the correct option. For regression coefficient, the comprehension decline is even worse. Only 27% of them actually understood the concept. And in Survey 4, 68% of the total students chose yes for self-reported perception. Interestingly, more students actually understood the concept than they thought they did, since 76% of students chose the correct answer. For comprehension, For comprehension of a data story recommendation, only 18.6% of students actually understood how to do data recommendation, leaving a huge gap between their self-perceived learning and their true learning performance. In summary, the data indicates a consistent discrepancy between students' self-perceived understanding and their actual comprehension reflected by the MCQs or MRQs assessing the same concepts. Though a significant proportion of students reported high confidence, their answers revealed limited comprehension. This suggests overconfidence, which is common in certain learning contexts, especially after surface-level exposure to new material. For topics such as symmetry and summary statistics, students' self-assessments were generally accurate, suggesting that the instructional materials effectively promoted both conceptual clarity and confidence. In the case of complex data comparison, the correctness rates even exceeded the self-perceived understanding, pointing to a potential underestimation of comprehension. Among the students' feedback, many indicated that they hope to learn more from our data story sets. Some of them mentioned that the data stories were also helping them to understand difficult concepts better. However, in contrast, topics such as correlation coefficient, regression coefficient, and data recommendation reveal a striking overestimation of understanding. For example, while 92.5% of students believed they grasped the concept of regression coefficients, only 27.0% actually answered the related question correctly. The gap was even more pronounced for data recommendation, with less than 20% accuracy despite high confidence. This indicates that students will need more help from these self-regulated materials when coping with more difficult knowledge. As this is an ongoing study on helping students in their introductory data science learning, we hope we can still improve the content and quality of our materials, as well as the design of assessment surveys to get more authentic and valid learning analytics. Thank you very much for listening. Please don't hesitate to contact us regarding our project. Questions are welcome. Thank you.